Okay, in this video we are going to look into building a Bluetooth RC controller interface so you can control an RC car or an RC robot, and the controller itself will be your smartphone, as you can see here, and I'm running an app on my smartphone called Bluetooth RC controller. So here's the main controls. I have my forward and my reverse. Now these are touch and hold controls, so if I press the forward and hold it, the car will go forward. When I release, the car will stop. So I have forward, I have reverse, I have left, I have right, I have forward left, forward right, and I have reverse left and reverse right. Now we have some on-off controls. I could turn on or off the headlights, on or off, or the tail lights, on and off. And there's the horn control, on and off, and a user function. You can hook it up to whatever you want. And we also have a speed control. It's a little slider to control the speed of your little robot. Okay, here's the receiving end of my RC controller interface. And you can see I have an HC-06 Bluetooth module. That's my radio link, and it's accepting commands from my smartphone app. And the LED on board is solid, so it's paired to my my smartphone app. So the functions coming into the Bluetooth module are sent serially into the UART of the microcontroller. And I'm using a Scamp2 board, which has a PIC microcontroller on board, which is running FlashForth. There's also a Scamp3 board as an upgrade to this board. And this board is controlling all the functions. You can see I have LEDs. I have my forward LED, my back LED, my left, my right, and then I have the three functions: headlight, tail light, and horn. So I can send commands from my app. So I'll send forward. You can see the forward LED comes on. There's back. It's my reverse. There's left. There's right. There's forward left, forward right, and reverse left, and reverse right. And I could send commands for the headlight on, headlight off, taillight on, taillight off, and horn. So next we're going to look at some advanced options that are available on the app. Okay, now I'm using the accelerometer on my smartphone. So now if I tilt it, there's my forward, there's stop, there's back, there's left, there's right. I go forward, right, or forward, left, back, left, and back, right. So there's another option we could use using the accelerometer of our smartphone. Okay, the next option is using the accelerometer like a steering wheel. So if I tilt it to the left, I get left. Tilt it to the right, I get right. Tilt it forward, I get forward. Tilt it back, I get reverse. So we can use our smartphone like a steering wheel to control our little RC car. Okay, next we are going to have a look at the control codes that are being sent when we press buttons on our controller. Every time I press a button on my controller, it sends an ASCII character by Bluetooth, and it's being received by our HC-06 Bluetooth module. Then the microcontroller can decode that. Now we have a list of the commands. If we go to settings, we scroll down. So forward is capital F, back is capital B, left is capital L, right is capital R. There's all the rest of them. There's our headlights, taillights, horn, speed. So every time I press a button on the controller, it sends an ASCII character code, and a microcontroller will decode that and then apply that to the motor control on our RC car. Okay, I have TerraTerm up and running on my computer, and I have it paired to my smartphone, which is running the Bluetooth RC controller app. So now when I press a button on my app, we can monitor the ASCII control codes that are being sent by Bluetooth. So if I press the forward button and hold it, you see we get an F. If I release, we get a stop. So press and hold, forward, release, get a stop. If I do left and hold, we get a capital L, release, stop. If I press my right control and hold, I get a R, capital R, release, get a stop. So if we do our on-off control, there's our headlight on, it's capital W, headlight off, lowercase w. There's our tail light on, off, and there's our horn on and off. Now there's another option. We could do streaming, where it actually will stream the character codes. So I could enable that. If I go into settings and enable streaming. So now it's streaming. There's our stop, there's our forward, stop, there's our back, stop, there's our left, stop, and there's my right, stop. So by streaming, it just makes it a little bit more reliable. Okay, here's the code running on the Scamp2 board on the PIC microcontroller, and it's written in FlashForth. Now when you're writing code in Forth, you're not building a program, but you're actually creating your own programming language, and we're going to see that when we go through the code. So the first thing we have to do, we have to configure the baud rate of the Scamp2 board to 9600 baud to match the baud rate of the Bluetooth module, and I do that here with the word 9600.baud. So I'm taking the value of 415 and putting that into the baud rate generator, and that will configure the UART to 9600 baud. Next we assign pin 12 as the UART input on the Scamp2 board. That's a receive UART input, so it'll be pin 12. Now I'm using these two words as building blocks to make this word uart.init, and that's going to run those two words. So you see how we're building bigger words with the smaller words. So the next will be the GPIO initialize. So we have 4 outputs for the directions. That's forward, reverse, left, and right. So it's pins 10, 1, 2, and 3. Then we have 5, 7, and 9. That's our headlight, taillight, and horn. So we're configuring all those GPIO as outputs when we run GPIO.init. So the next word is forward. That turns on the forward LED. So when pin 2 goes high, it will turn on the forward LED, and the rest of the pins are low. Same as when we turn on the back LED for reverse, pin 10 will be high and the rest will be low. So you can see how that works. So it's very similar to all the rest of them. So we got left, we got right, we got stop, forward right, forward left, back right, back left. And there's our headlight on, so pin 5 would go high, headlight off, pin 5 would go low. There's our taillight, there's our horn. Kill, it shuts off everything. So here's our main word, it's called RC for radio control, and this is running in a continuous loop. So the first thing it does, initializes the UART, initializes the GPIO, shuts everything down before we start, make sure everything is off. Then it starts, it goes into a begin again loop. Now here it's going to sit in this loop, waiting for a character to come into the input UART buffer. This is the flag, RX2 flag, and as soon as it sees a character into the UART receive buffer, it'll read it. Then it's going to compare it to all these values. Now these values are ASCII code in decimal. So if it sends a capital F, that's a ASCII 70, and if it's matched, it will run the word forward, which will turn on the forward LED. If it sends a capital B, it will be a 66, and if it matches, it will turn on the back LED. And there's a left, there's a right, there's a stop. So this is running continuously and running all this code depending on what is being sent from our app on our smartphone. So you can see all these words: kill, horn on, horn off. These are all words in our language. So this is a language now for our RC car. Now we could give these words to somebody who's a beginner, and they could actually use them as building blocks to build their own program. Now when you're coding in Forth, it's very easy to troubleshoot because you could run all those words that you built independently at the OK prompt and test them out. So there's no need for a debugger. So what I've done, I've taken away my Bluetooth module, and now instead of getting input from my app, I'm using my keyboard. So this is a way we could actually troubleshoot. We could actually take out the Bluetooth and run it directly from the keyboard. So now if I hit on my keyboard, if I hit those ASCII values, so if I hit capital F, you can see the forward LED comes on, B, back, S will be stop, L, left, R, right, S, stop. You could turn on the horn, tail light, so that we could independently we could test each word, and we could make sure the coding is working. Now we could add on our Bluetooth module and go from there. Okay, so that was my little tutorial on how to build an RC interface using a Bluetooth module and a Scamp2 board. So now it's up to you to take the output, the 4 outputs, the logic outputs, and feed that into, say, simple relays or into a motor controller board to drive your motors for your RC car or your RC robot. And I'll have a link in the description box on how to program HC-06 Bluetooth modules in case you have to set up the baud rate. Also, I'll have a link to the code that you could run on the Scamp2 board. So I hope that gave you some information how you could build one of these setups and you could get your RC control project up and running.